The date is the 20th of June. Hello and welcome to Beyond Bitcoin. I'm Arthur S. Falls. Join me and my guests on our weekly stroll through the fields of second-generation cryptocurrency. Remember, nothing you hear on this show is investment advice, so don't you scamps go running off putting your money where you shouldn't. Give it to a reputable fiduciary, or sew it into your mattress. While we're doing disclaimers, I do invest in this stuff, often in the currencies or platforms we're talking about, so there is probably a conflict of interest here, or an issue with journalistic integrity, or something, I don't know, I just believe in the technology. The block hashes really must have collided this week because we have a deep exploration of not one, but two of the most innovative second-gen platforms in existence. First up, Dan Larimer of Invictus Innovations plows exhaustively through the entire BitShares platform, from delegated proof of stake to the BitShares X exchange. Next up is Next, or NXT. A fellow named Ian was good enough to sit down with me and pick through the plumbing of transparent forging. We also discussed the plethora of new assets available and the never-before-seen features on offer. The evolutionary construction of Next is a thing to behold, and Ian was a fantastic guide. Hold on to your hats, guys. This is going to get educational. Hey Dan, it's great to finally meet you.
Yeah, how you doing?
Good, man. Great.
So what's the scope and purpose of this call today?
Well, way back when, Invictus debuted with Proto Shares on Momentum, and that was a memory hard proof of work algorithm, which made a lot of sense to me at the time. And since then, you shifted to transactions as proof of stake, which was, at the time, again, a perfectly sensible move to me. In fact, your shifting to transactions as proof of stake kind of legitimized the idea and really made me take notice and caused me to actually look at that as a new paradigm. But then you made the shift to delegated proof of stake. And for me, that was obviously a completely new thing and a totally new thing to wrap my head around. What I'd like is an outline of delegated proof of stake and how it functions and what the network looks like. And then I'd also like to understand the thought process that was behind the changes that led up to it.
Okay. Delegated proof of stake came about as a solution to the problem of who gets to produce the next block.
Okay.
With transactions as proof of stake, we had a metric for figuring out what the best blockchain was, but not who gets to produce the next block. So not having the solution of who gets to produce the next block is, all right, now you're going to have lots of forks, or you need to have some way of preventing everyone from going at once and basically orchestrating people to one person go at a time. So Bitcoin and proof of work does that by making it difficult so that statistically only one person is going to find it. As soon as you remove proof of work, now you need some other mechanism. We look at various hybrid models before we went to delegated proof of stake, where you had some like low-level mining to figure out who produces the block and then have someone produce the block.
Because you had low-level mining in Quixote.
Well, yeah, Quixote's the original idea of the Quixote blockchain was that you would mine your identity and that you'd merge mine your transactions with the blocks, and new users signing up would secure the blockchain. It kind of depends on having a steady stream of new users signing up, or renewals, people that want to keep their accounts renewed. But I've come to the conclusion that even the Quixote chain being based on proof of work isn't necessarily the best way to go. It's inefficient and doesn't actually provide you any security.
The reason you didn't want to stay with proof of work was primarily inefficiency, or is there could you explain the security reasons behind that?
Yes, the security, the reason we noticed with Proto Shares or PTS was that miners would produce blocks without any transactions because it was profitable to do so. The other is that people were spending $100,000 a day mining PTS, and that was just money that was being burned. So recognizing that, you say, well, gosh, what if that money could be spent enhancing the community, enhancing the blockchain, improving development. That would really change the landscape, change the equation, change the possibility of success. The other thing that's been developing over this entire time frame, from the first beginning of BitShares until today, is the idea of viewing these things as companies in the market that must compete to produce a product profitably. And if you have these expenses, you have to pay the miners in order to get security, then you're not going to be able to do that profitably. There's the other aspect to mining as far as not being secure, and that is that your security is directly proportional to how much you're willing to burn. So there's a linear relationship between your security and how much money you're burning. You'd ideally like to pay very little and get a whole lot of security. And so that's where proof of stake comes in. And delegated proof of stake is just a way of facilitating the allocation of stake, recognizing that most users aren't going to be available all the time, that having a large number of highly reliable nodes is better than individual users randomly being online. So there's a lot of factors here, but we're basically taking the metaphor of a business and profitability and delegation of roles and responsibilities to just basically applying the whole metaphor to the entire system. And it's yielding great results, both from a technical side and from a security, efficiency, possibility side.
Could you explain what the performance advantages look like for delegated proof of stake?
Well, with delegated proof of stake, you have a predictable block being produced at an exact expected time with near perfect reliability. Well, assuming you've elected decent delegates, they'll have near perfect uptime and high bandwidth connections, and they'll be highly connected to the network. What that means is that we can process more blocks faster than any other system, even, say, Ripple.
Even faster than Ripple? What was Ripple is down to seconds, I thought.
So Ripple is currently operating on 5 servers, all hosted by themselves. All the servers have to agree on what the next block is going to be. So there's this agreement protocol. And that time it takes to reach that agreement slows down the theoretical rate at which they can produce blocks, particularly if you grew the Ripple network to be distributed among 100 nodes across the world. All of a sudden, speed of light and latency issues would mean that the round-trip time for even a single message is on the order of half a second if you're going to China from the United States. These types of latencies mean that if you're going to coordinate with multiple people in multiple countries, that the theoretical block production rate is much lower. But with what we're doing, only one person has to agree, these are the block transactions in the next block, and they broadcast it. And so there's not that coordination step with everyone else.
With only one person agreeing what transactions should go into a block, isn't there a risk there of abuse?
Well, there's a new person every 15 seconds, so you have to get all the delegates to exclude a transaction. And so you go through 100 delegates, and basically in very short order, every delegate out there has a chance to include transactions. And if they're not including transactions, then they're going to get voted out. And it's also very detectable. It's really very simple. Right now, you can think of the shares as votes, and every vote belongs in a bucket. It's either for or against a delegate. And so when you move your shares from one queue to another, you're also moving your vote. So you take it out of one bucket and you put it back in another bucket. And whichever delegates have the most net votes for minus votes against, the top 97 gets to take turns producing blocks.
And so how do those votes get allocated to the delegates?
in our web wallet, you have a list of all the delegates that have registered as candidates, and there's a little thumbs up or thumbs down arrow next to it, and you can say whether or not you trust them. And then every time you make a transaction, the wallet will look at who you trust, look at what the current ranking is, and figure out if they should vote against or for someone automatically on your behalf.
And if you don't make decisions yourself about who to vote for or against, will your web wallet or will your wallet automatically make that decision?
Yes, the wallet will automatically make decisions for you if you don't set any preferences based on its own observations of the network. So if there's some delegate that hasn't been producing a lot of blocks and you're lazy, you're just going to vote against them.
Okay, cool. So the criteria for voting for or against a delegate would be the speed of its block production, and it's presumably it's up to its reliability, the fact that it's always producing transactions. Am I on the right track?
Exactly. There's lots of factors here with how it goes. Is the delegate performing good services for the community? Are they doing anything extra for the community? What's the technical performance, latencies? Are they showing any bias in their processing of transactions? And assuming they've good on all accounts, so a lot of those things are observable, we can gather statistics and give the user advice for automatic voting. But I suspect that where these things can actually go is it can allow for kind of like a giant board of directors, and you can allocate how resources of the DAC are reinvested to grow the DAC.
Is there so that's really interesting. So the funds that are given to a delegate in return for processing transactions can actually be pledged by the delegate for a certain purpose, and in order to get those votes.
Exactly.
And which would allow them to reinvest the money spent by the public, or by the users processing the transactions.
Yep.
Oh, that's really amazing. That's a really clever mechanism.
So now, if this was Bitcoin, instead of having 5 mining pools and all these guys spending all their money on hardware so that they can make a small, couple % profit, you'd have 100 people all competing to earn, Bitcoin's got 10% inflation, 500 million. So if you're the size of Bitcoin, you've got $500 million a year, split among 100 delegates. There's $1 million budget per delegate to pledge for reinvesting in various things.
BitShares aren't inflationary, though, are they? They're not inflationary, but they don't have any stake dilution taking place, do they? We're building a toolkit that allows you to design it in different ways. So stake dilution is actually something I started out 100% against, coming from a monetary perspective. But coming from a business perspective, companies dilute shares to reinvest, to raise capital necessary to grow the business. So if you were to tell a startup company that they're not allowed to dilute their shares, they won't be able to grow. So you have to view these things differently. And that's really been enlightening for me is, well, let's just completely apply the company metaphor to everything we're doing, and we'll learn and gain from all the experience from centuries. And so I think as long as the price goes up more than the dilution and the shares are being diluted to productively grow the company, then the dilution's increasing shareholder value. So you might own a smaller amount, but it's worth more. And that's still considered profitable in my perspective, because you're increasing the value of the assets held by someone. Yeah, that makes perfect sense, but at the same time, it kind of goes against my intuitive feeling. There should be a kind of an immutable social contract from the outset with these things, as opposed to one that can change over time with potential outside investment.
Well, yeah, so having an immutable contract is part of what makes DAX valuable. So figuring out what that contract should be and designing it in the wisest possible way before you set out is going to have a big impact on your long-term success. Now, I'm just pointing out that if you had 2 DACs, one that paid only transaction fees and one that diluted at the same rate as Bitcoin. In one DAC, you'd have a bunch of delegates being paid just enough to cover their hosting costs. And the other DAC is you'd have a bunch of 100 delegates all competing and lobbying in the marketplace for votes to have the right to allocate $1 million a year each to grow the DAC. Which DAC do you think is going to grow faster? As well as all the publicity associated with people fighting over that cash.
Yeah, right. It's a much more dynamic than just the standard original DAC concept that I had in my mind of just this static entity that sat there and processed the interaction between people, or guided the interaction between people in a way that was efficient.
Well, you're still doing that. You're guiding the interaction between people. And this is where delegated proof of stake gives us a huge advantage over the other proof of stake systems, because we have the ability with our continuous voting to actually give the shareholders the power to control how and what funds are invested in, how and which direction the company should grow. Any other proof of stake system, they might have security, but you, from what I can tell, have no way of ensuring that the delegates do anything productive with their shares. You don't have a way of voting people out. It's also diluted. You have to have shares to get shares, whereas you can be elected a delegate without having any money yourself.
Okay, and what this sounds a bit like cooperative proof of stake, which we've heard about from Stephen Reed. I've been trying to get him on the show. I'm sure I'll track him down before too long. Is this a new trend in the design of these block publication systems?
I think as the industry is maturing, what you realize is that these systems are more about transparency, irreversibility, and making things unambiguous. That the proof of work model is just one way of trying to get those things, but there are many other ways of getting those same things. It's all about cooperation. It's all about the social contract. It's all about people agreeing to work together. And they agree to work together because the rules are well defined. So the concept of having it be random is no longer necessary. What's necessary is having it be predictable, having it be transparent, and no barriers to entry.
As opposed to the massive wall of hashing power.
Yeah, I started this whole thing with Bitcoin's ever paying for security or false security, and just because you say it's security doesn't make it security. It's like hiding under your blanket and saying you're secure. Well, secure from what?
It's a pretty thick blanket.
Yeah, but it's only covering one side.
That's interesting. Yeah, you mentioned that because I always thought that hashing power was, in fact, or the proof of work mechanism was a bit of a workaround because it allowed an external force, the actual hashing power itself, or the distribution of the hashing power, to infiltrate the game theory structure that it was designed to support.
Exactly.
Whereas, you get these huge pulls.
Proof of work allows the DAC to be taken over irreversibly by computational power, by economic might. It serves as a barrier to entry. It separates the shareholders, the people who own the coins in the system, from the control. So one person gets control, the other person gets, they're subjected to the control. And that's what we're trying to rectify with what we're doing. Proof of stake puts the control back into the hands of the shareholders, and we further increase their control. And what that gives us is the ability to say that we can actually have some centralization in the 100 delegates with large server farms and high bandwidth requirements and all those other things, while still keeping the shareholders in control because they can be voted out and lose their source of revenue necessary to fund their operations. Whereas if Bitcoin miners take over, what do the people who hold Bitcoin do? They can't clone Bitcoin because the miners own anything that's based on proof of work. They'd have to switch to a new proof of work. And once the miners have generic hardware that can handle any proof of work thrown at them, then it's game over.
This is actually a bit like centralizing one part, or it's still decentralized. 100 delegates that automatically switch between every 15 seconds. That's still extremely decentralized.
Well, especially when you consider that the number of delegates can be switched with changing a few characters in one file.
Yeah, totally. And also you've got the influence over those delegates is perfectly distributed by stake, isn't it?
Yes.
Well, not stake so much as actual transaction volume. So
not transaction volume by stake.
it is distributed by stake.
Yes. Every time you make a transaction, the votes come from one person and go to another person. So when I send you money or shares, in addition to sending you the shares, I'm also transferring votes from one person to another person.
So this is not based on transactions at all. You actually are. It's because I still have transactions as proof of stake in my mind, but in this case, the actual stake that is represented by your private key that you're voted by, the private key you're voting with, is your voting power.
Yes. In fact, I'm seriously considering rebranding them from shares to votes, and that you have votes and you can sell and trade your votes, but they're not shares in the company or a DAC. They are just votes in the DAC, and you can reallocate who has control over those votes.
It's amazing how you wind up going down this down the rabbit hole of metaphors, trying to understand how exactly these systems work. Currency made sense for a while, but it's just not a metaphor that's going to last into the future. And yours was really interesting with the company metaphor, and now to also think of them as votes, to also think of stake as the percentage of your influence is.
You can think of it as a decentralized autonomous country, where the citizens have votes, one vote per share, and you can immigrate, or to or from by buying shares.
Wow.
Or buying votes.
And it's still a DAC.
Still a DAC, yes. And so I'm actually in favor of that particular metaphor these days because it accurately represents the delegated proof of stake concept, and it represents the idea of influence and decentralized control. It also influences carries with it the idea of a community. These things are worthless without a community behind them. It's kind of like a country, your home country. So it's a way of having countries without territories.
And that's really fascinating, because really, in a sense, that's what we're trying to move toward, is unbounded by geography, but still able to cooperate.
So, these things allow people to form their countries. The countries compete. And if you view these as votes in a country, then it's almost like back to the currency metaphor. What's the currency of your country? Oh, the votes.
Wow. Yeah, well, I mean, because it is, all of these metaphors apply perfectly in their closed system, but then it's just that this enables so much more than just a share, just a stake, a currency, or a vote. There's so much more going on there that there's no metaphor that really encompasses everything that a token on a blockchain can be. But at least it's really great to see that you're exploring these different avenues.
We are trying our best to understand it and help others understand it. It's through understanding that you can innovate.
Yeah, it's amazing because there's talk about voting, dynamically moving the vote. NoirShares is an interesting project that has centralized leadership, and they're using Momentum actually for a proof of work algorithm for their mining, and then they allow you to dynamically shift your vote between. I believe they allow you dynamically, or maybe you vote for tenure for an individual. Mm-hmm. Anyway, moving on to something completely different. Titan is I heard you guys speaking about that on one of the Hangouts recently, and it just struck me as one of the simplest solutions to two of the most significant problems that cryptocurrency faces. From an adoption point, and then also the security side of things. Could you explain how that works?
Yeah, Titan stands for Transfer invisibly to a name or to any name, and it uses some cryptographic techniques that have actually been around in the community for a while, known as stealth addresses. But stealth doesn't sound as powerful as Titan. And it only covers one part of the problem, right? Stealth addresses is all about addresses, and Titan is all about names. So when you combine the ability to have a phone book of public keys that you can then use to send securely and anonymously to someone, you really solve the ease of use question, which is the bigger, more important issue in this entire space. So if you've looked at some of our beta wallets, or alpha wallets, depending on the perspective you take, you'll notice that every transaction has who it's to and who it's from by name, and also a memo included in there. So you can use the system without ever having to look at an address or a key or any of the stuff that scares users away. You no longer have to exchange addresses with the people you want to do business with before they can send you money.
That's essential. I mean, I've been using Bitcoin for over a year now, and I've been trading, and so I make a lot of transactions, and everything's gone smoothly and without a hitch for about a year. And then not too long ago, I just somehow misspelt an address and destroyed a considerable sum of money. It's embarrassing, but the thing it made me think of was, wow, if I can screw up this badly, what would happen when you try to give this to the public and, someone just wipes their paycheck?
Well, I won a bounty or a tip from the Mastercoin people for 3 Bitcoins. And they asked me to give them an address, so I copied an address from my address book and I sent it to them. I copied the sending address instead of receiving address. It went to some random person out there.
No way.
If that can happen to me...
Yeah, it's crazy. Actually, that's exactly what I lost as well. Oh, that makes me feel so much better, Dan.
Doesn't make me feel much better.
No.
But, some lucky guy out there that I had done business with in the past got an extra 3 Bitcoins.
Well, at least yours are in circulation. Mine are just sitting there. I can look at them on the blockchain and kind of try to move them with the power of my mind back to my wallet, but I haven't had any luck yet.
Yeah, so this is the thing we solve. Now you can just say, send it to Dan, send it to whoever it is you want, and it's going to go to them.
And underneath that, you have these multiple addresses that are...
Yes, the security is automatic. Exactly. So the fact that there are addresses under the hood is some technical implementation detail that the users never have to think about. To be clear, Titan doesn't completely solve all the problems, other than it ties the threads together at fewer points.
What further problems would you say there are to solve?
Well, you need something like zeroCoin to completely break the thread of being able to follow things. Yeah. So if you can think of Titan, what it allows you to do is you've got a dollar bill, and you can transfer that dollar bill between people, and no one knows if you're transferring it to yourself or to someone else. It's just one input, one output. Whereas with Bitcoin, every time you make a transaction, you're combining several of your addresses, and you're sending it to someone, and you're getting a change address. And all these things end up creating ties between your various addresses. And they do that because it's really difficult with Bitcoin to create a new address for every single transaction. And if you wanted to do this properly with Bitcoin, you'd have to, if you wanted to send me money, I'd have to give you multiple addresses so you could send me it in parts, so that you don't actually have to combine any of your values together and tie them together.
Link your addresses that you've got those Bitcoins spread across.
Yeah, Titan eliminates the need to exchange addresses, which means that you can avoid the linking in the first place, which provides a lot of privacy protection, but there's still the ability to track payments from one place to the other. But it's a lot easier to launder.
Oh, thank God for that. There's actually something else that just popped into my mind, and that was something I read on a forum, on the BitShares forums, that you guys had changed your means of how your how the information is structured in your blockchain. You're no longer representing every transaction in there anymore, are you?
The way Bitcoin works is a transaction is defined as you take inputs from one spot and you put outputs to another spot, and everything links from one place to the other. And every output can only be spent by one input, and that creates this gigantic chain of transactions. And that works fine if the only thing you're doing is a currency. But as soon as you start doing other things, name registration, markets, you have all these extra databases that aren't represented by that model. You could try to represent them by the input-output model, which is how I originally designed the system. But it created a lot of additional complexity. You end up having to have a secondary index and then generating all this extra overhead in your blockchain, so that every time you want to change anything in your database, you have to take it as an input and create a new output. So we changed the model to say, well, it's just a database, like any other database people are familiar with, and you're performing operations on this database. For those familiar with databases, operations are grouped into what's called a transaction, and either all has to happen or transaction fails. And that's how, if you're going to update multiple records in a database and something fails, you roll it back and you're fine. So we just took the traditional database model and we said, all right, we're going to define the operations that the user can perform and use the exact same model. Now a single operation can update multiple records in the database as long as it does so in a valid way, with just a single command in the blockchain.
So why has no one done this before? This seems like it would reduce. This seems like it would be. Yeah.
People have done things like this before. It's called like accounts. I think Ripple uses accounts, and it's updating the accounts rather than the input-output model. So it's definitely something that's been out there. I was originally going down this approach when I was designing BitShares, but the reason I ruled it out is there's this challenge. Well, how do you make sure you've got the right database state? And how do you work that state into the blockchain? Sort of some kind of global hash of the entire state of the system, and that just didn't seem scalable. But I've since discovered that you don't need to maintain that information, and the delegated proof of stake allows you to, at any time, replay the operations and get back to the proper state. And I'm not trying to synchronize the users to some state by downloading the database. You apply all the operations and you recalculate it. So by removing that requirement, I got rid of all the complicated Merkle trees, if for the technical terms, that people like Ethereum are trying to use to encapsulate their state and embed a hash of that state into every single block they produce.
But doesn't this allow? I mean, you said before it needs to be transparent and irreversible. Doesn't this imply a degree of reversibility, or is that conditional on?
Irreversibility is all related to the transparency. If you have a transaction record that's public, it's the user consensus of what that record means that makes things irreversible. In the case of Bitcoin, the consensus is longest blockchain wins, which means that all transactions are reversible if you have enough money.
Right.
With our system, things are irreversible once enough delegates have signed, which means it's much quicker. And it doesn't matter how much money you have, you can't go back and change it because it's already been committed to the public record. And so that's where the irreversibility comes from. What we have here is a system where the delegates can manage huge databases with high bandwidth, have the ability to synchronize and keep up with all this, and provide services to lightweight clients. The challenge that these proof-of-stake systems have is that there's no way to validate, to do a lightweight validation. In the Bitcoin network, you can validate the network by saying, well, how much work has been put into it? And you can just look at the block headers, which is a small amount of data, and say, yes, all right, a lot of work's been put into that. I trust it. And with proof-of-stake, you don't know if it's a valid chain without having the entire chain. So you can't take that shortcut.
Because you don't have the proof of work metric to go by.
Right. You have to know what people's stake are, but people's stake is changing every time there's a transaction. So you don't even know who's supposed to sign the block. You can say, well, a lot of people that I'm talking to seem to think that this is good. So what we have in our system is a better alternative than just using the raw proof of work metric. And that is the ability to fire delegates that sign something that's false. So if you claim a transaction is valid when it is not valid, you claim a transaction has been included in the blockchain and it hasn't been included, someone can submit that, hey, here's your signature on this, and you can be fired for it immediately. And that if you're a delegate that's earning $1 million a year, then you don't want to get fired, so you're not going to sign anything that's false. And that's probably all the more security you need for, it replaces the need for looking at proof of work.
Yeah, well, of course, because that's there's a strong disincentive there. There's a perfect disincentive to attempt to obscure anything. And I'm trying to think of a way that I, as a delegate, could abuse that position. So you don't know, you randomly switch between delegates as well, presumably.
Yes, delegates operate in rounds. So you get 97 delegates. Every 97 blocks, they get shuffled, and they all produce 97 more blocks.
But is there a point in there where the delegates could collude? So when they shuffle, do the delegates know who's coming up? Could they?
Well, everyone knows who's coming up for the next round, but you're not able to predict the next round unless you have all the delegates colluding. The system works as long as there's even one honest delegate.
Okay, that's pretty secure.
Yeah, well, actually, in practice, it's all these systems is a 51% attack. So 51% of the delegates decide to collude. They can
say the other guys.
They can pretend they can pretend the other guys never produced anything. But yeah, so as long as 1 out of 51% is honest.
Well, that's comforting. Yo, I'm just getting organized to be one of these delegates myself. So
with things we're planning, being a delegate, there's going to be 2 roles. There's going to be the like the politician, here's my budget, here's what I want to do role, and then there's going to be the technical role. So one person controls the funds, the other makes sure you have the uptime. So you can actually hire people. So anyone can be a delegate if they want to take on the role of promoting, marketing, growing the DAC.
Yeah, that's interesting because it allows groups to cast themselves as delegates, and kind of like mining pools, only you know that there's going to be at least a certain number of delegates as laid out in by a single number in a text file.
Yes. So we basically took the mining pools, which are effectively the delegates in Bitcoin, and said instead of having 5 of them, let's have 100 of them. And instead of making them self-appointed, let's have them shareholder-appointed.
How does this transfer down the chain of BitShares, BitShares-based DACs? Can they all use the same delegates or have their own delegates?
Well, every DAC has its own delegates, but the same person can be a delegate in multiple DACs.
Let's go through BitShares itself then. Can we have a look? Because BitShares seems pretty ripe for release. I know this is the most boring question imaginable. Could you give us a time frame and a brief overview?
All right. Well, BitShares is the entire philosophy. We are creating the BitShares toolkit, and the goal is to make it easy to adapt new rules, to build new systems. And we've got many such systems under development. We've got a voting system we're working on with Virginia Tech that's based on zero coin technology. We've got a DNS system that Nikolai, or Toast from the forum, is working on that eliminates domain name squatting. And then we've got our flagship, BitShares X. It's our bank and exchange that allows you to have digital assets with all the properties of Bitcoin and the price stability of the dollar, gold, or silver, and to trade them in an entirely decentralized manner. So those are the various things we've got coming down the pipe with BitShares and our toolkit. Where we are right now is we are actively testing with delegates like yourself, if you signed up, to find any bugs in the base system. This is the ability to have shares, to issue assets, to every DAC has the ability to have proposals submitted and voted on by the delegates. And all these things are being tested with the delegated proof of stake, our networking code, right now. And you can download wallets, compile wallets, and participate in some of our tests. And those are going very well. Obviously, we are resetting the blockchain about once a week. We're on about our fourth or fifth iteration of this process, but each time we are getting closer and closer to having something that can be launched and used. So I'm hesitant to give timelines because you never know what's going to crop up in the development realm, but anyone who's participating can see exactly what the state is. We've recently released a test GUI client for the Mac, and that's rapidly maturing, so I would expect that this summer you'll see a lot of things. Coolest thing we have going on is that all of our developers are now working in one room. We've got 6 people here now, with another 2 coming next week. So that's greatly enhanced our efficiency.
This you've got a toolkit to allow anyone to build on the work that you guys have already done, with presumably about 95% of the same code, and produce their own DAX for their own purposes. You also mentioned that you had assets that could be traded with the price stability of gold or, say, fiat currency. Mm-hmm. How do you get that price stability? Do you use some kind of options contract that's built into your system?
It works the same way that a bank does. You lend dollars into existence backed by collateral. If the collateral falls in value, you do a margin call and you pay off the loan. All that stuff is implemented on the blockchain.
Okay, and that's how you issue and.
Yeah, the collateral in this case is shares in the bank itself. So it's like going to a bank saying, "I'd like to borrow some dollars." The bank says, "What do you have for collateral?" "I've got stock in the bank." "Great, here's some dollars." And now, as long as the stock is worth enough to back the dollars that you've borrowed, you can maintain your short position. That's what's called going short in the market, is when you borrow and sell. And then if the price of the dollar goes down relative to the shares, you can buy them back later and make some money. So you have 2 parties there. Those that have the dollars, and they get the price stability, and the speculators who are taking a leverage position against the dollar or the gold or the silver.
You're basing this asset on a cryptographic asset on a prediction market for an external asset, effectively.
Yep.
To get people using this internationally, they need this. They need the price stability, and that seems like a solution to the problem, which is awesome to hear. Finally, you know.
Yeah. It's a solution I invented a year ago, and it's taken me from then until now to get even close to realizing that it's an amazing amount of work to release a crypto system.
Apparently so. You know, you must be a real Trojan, Dan. You've copped so much flack over the years just for promising so much, and you've drummed up so much interest because everyone's so excited to see what you produce. And then it's like you said, with time frames, you never know what you're going to run into.
Yeah, well, I started out trying to do everything with proof of work, and I had to reinvent the entire architecture of the blockchain before I could get to what I originally set out to do. So I think we're finally to the point where the core architecture is there, and now I can do the small little bit of work of actually implementing the thing I set out to do, now that I've got a solid foundation.
Hello, Arthur. So I've been in the technology industry all my life. I currently work in the area of real-time financial services anyway. And so I started exploring digital currencies about June last year, and started with the obvious ones. And got into mining and stuff like that, did okay. And then started exploring deeper into the forums, into Bitcoin Talk. And basically I came across Next probably in December. And being a technologist, what struck me, because I found the whole kind of technology around the kind of Bitcoin and its derivatives a little bit clunky, and couldn't understand, why it was so computationally expensive and all the rest of it. And then I came across this platform that was using Java, that was aiming to be quite open, cross-platform and computationally efficient, and as a technologist that attracts me, because that's what I seek to do anyway with the systems that I build today. And a lot of real-time financial systems today are built in Java because it gives you guaranteed behavior on different platforms. You can test it once and then deploy it in lots of places. So it gives you a better characteristic than more traditional programming languages like C++, C, which are more bound to the hardware that they're running on. So that's how I came across it. And I think you've already heard from Basil in the community, and all I'm going to say is that's the other component. I'm not going to repeat his discussion with you. I think that's the other powerful thing that then helps exploit the technology platform and start to put it to use.
So when you look at Next, what is it you see in terms of a future for the technology, and what do you want to turn it into in a personal kind of way? I mean, do you have a plan for Next yourself?
The thing I like about the platform is it already does four things. You already have the coin, if you want to call it that, a token of value that can be passed between people on the blockchain. You already have a block of information that can equally be passed and secured. You've got a namespace, and then you've got additional kind of asset tokens on top of the blockchain as well. So you've already got four things that you can put to use for different applications. And what I think I'm seeing coming with future features is the kind of choice of a platform like Java and an algorithm which is not computationally expensive, meaning people are able to focus on function and look at deploying more features and more functions on the platform that make sense, okay, in terms of decentralization or a blockchain-based mechanism helping validate transactions between people of different types. Yeah, and I think that's led to a very open system which people can integrate with in a very straightforward way. I mean, Next provides two APIs, a very, very high-level one, which is almost like just calling web pages, which you can build scripts around very, very quickly. And a much more lower-level one, a Java API, which, for example, the default client uses. But the openness even extends to the client itself, because the client is built in JavaScript, which in itself is open and cross-platform. And actually, people are able to take components of that and build their own clients, which I would hope to see things like that starting to come out in the future. There's already one encrypted mail alpha client which I've seen called CryptoMail, There's talk of we've got the asset exchange, but in the default client, it's a little bit kind of basic. It's good, it's performant, but you haven't got all of that kind of trading information around you that you would have on a trading website. It would be very easy to take the JavaScript components of the client and build them into a trading website.
I see what you're saying, and your background is in financial services, so this is something that I suppose you're involved with this in the.
Well, no, I actually because that's my kind of profession. I see that as a slight conflict of interest while I'm still employed. So basically, I'm working with some guys on building a role playing game that's kind of taking some of the principles of Next and trying to build let's say a role-play game where you still get the game behavior, but there's a level of decentralization of the game information. So anyone can, for example, run a server to support the game, but they can't mess with the game database. But that project's in its early stages now. We're just launching the funding for that.
So in that game, you're looking at exploiting the tamper-proof ledger of Next to record game information, and then also, I guess, so your Next would be like an in-game currency. Am I imagining this correctly?
Yes, we may use an asset or what I call a light clone of Next, because we may want some faster block speeds and things like that, and we may want to be able to do things, but we would essentially be using the technology itself directly.
Next is the only currency that's actually experiencing this kind of lateral development, I guess. Everyone else they're doing their stuff, but Next is really casting the net much wider as far as innovation goes.
I think it's benefiting from a fresh start with a very modern kind of set of technology underpinning it. I think there are other coins or other platforms, I would rather say, coming along. But they're not here yet. So I think Next is enjoying the space at the moment of being, I think, one of a kind.
So I guess you talked about transaction times, and I may as well dig into some more technical stuff. I am a total layman personally. At the same time, I'm really interested in comparing how these things operate under the hood. And so you say faster transaction times. I'm not 100% sure what Next is running on, in terms of a block publication algorithm. I know you guys are looking at moving to transparent forging, and I really want to get onto that. But what's Next using right now?
So at the moment, Next uses a proof of stake to determine the next forger of the block. And I think the other important thing to say is Next is recycled. It's not created. So it's 100% created at Genesis. Each transaction carries a fee with it, and the node that forges the block gets the fees from all of the transactions in that block as the reward. People comment that they don't make a lot out of forging, but actually the way you earn money, I think with Next, the way I like to say it is you put it to use. You don't earn money with Next by buying a bigger computer because you can afford one.
No, well, that takes place outside the game. You're not bringing value to the network by increasing hashing power.
No, it has absolutely no consequence whatsoever. So the way the forger is determined is quite straightforward. The network of nodes has a target, and the target's the same across the network, and it's based on the previous target and the time since the last block. So as the time increases, the target increases. Okay? And then so the idea being a smaller number is a smaller target, a larger number is a larger target. If you think about it like that. Then each forger can calculate a hit And the way they do that is it's based on the value of the last block that was generated and the public key of the account that's forging. So basically, once the previous block has been generated, pretty much every forger knows whether they could forge the next block, because they will know if their hit value is less than the network target.
You're only exploiting a small number of values there, aren't you?
Yeah, but it effectively the hash of the public the hash of the block signature and the public key. We take a component of that, and that basically generates a pseudo random number, in that you can't know that number until the previous block has been generated, but once the block has been generated, you can know that number.
So that's how you're currently doing it.
Yep.
And so the shift to transparent forging, which I understand is in the works, I'm not sure what the time frame for it is, but could you explain, I mean, A, transparent forging, and B, I've heard it referred to as the element that next as genuinely next generation.
I'll describe it the way I understand it. Not developing it, and actually the development of it is quite close to the chest, because it is such a valuable component, and I know it's being built in stages over the coming months. So you will see changes in upcoming releases moving us towards it, and we may change some of our current forging algorithm as we go. But essentially, what I said is, once the previous block is generated, each forger can calculate whether they could forge the block. So let's say out of 100 nodes, 5 nodes think they could be the one to forge the block because they've got a hit below the target. Okay?
Yep.
They could well all attempt to forge, but only the one with the best hit will succeed currently. So the other 4 would be penalized, as in they forged when they shouldn't have done, and they won't be able to forge again for up to 24 hours.
Okay. So there's a time limit associated with... Yeah,
that penalty's built in to actually prevent people messing around with the forging piece. So I understand it. Now, imagine that when the previous block is generated, you could actually, if you know all the peers that are on the network, which you do, therefore you know all their public keys. Therefore, you can quickly do a computation to determine who the next forger will be. So every node on the network can go through the list of forgers, based on the block value and the public keys, determine who will get the best hit.
So you know in advance whether or not you're the person who's going to be...
So yeah, and you can do that. You can do that computation in a very small amount of time, but you've got 60 seconds between blocks. What you can then do, the thing about transparent forging is it's transparent. I know who the forger will be. So how does that help me? Well, one of the issues with processing transactions is getting it to the node that will forge. And typically at the moment what you do is you just broadcast your transaction, and it goes out through the peer connections, and it propagates across the network, and when it finds a forging node, it gets included in a block. I think you can understand where I'm going is, if I know the IP address of the next forger, I can do a directed transmit of my transaction to that forger.
Which reduces latency and...
Yep, and as long as the block isn't full, I'm guaranteed to have my transaction included.
Okay, and what if the block is full? Does that just it bounces back and then you rebroadcast?
Well, no. The transaction is. I don't know the full implementation, but once your transaction has been broadcast, it was already propagating, so it will get picked up in the next block anyway.
Okay. And so so with transparent forging, basically that gets whittled down so that you know the individual who's actually going to be forging, but not the next person down the track.
Yeah. Yeah. And I don't know the final implementation, but in theory, if I was writing a client and I knew all 5 or however many forgers that could forge, I could direct my transaction to all of them on the basis that one of them might fail for some reason. And if it doesn't forge, the next one will successfully forge.
Right, and so you've got that redundancy and it's propagating through the entire network, which is that's what everyone else does, isn't it?
Yep. But the principle is essentially to have a way of determining between blocks who the forging candidates are. The specifics of the algorithm may evolve over as we go through the implementation.
Have you heard of delegated proof of stake and cooperative proof of stake? Those two paradigms that are being explored.
Do you mean stake leasing as we have it in Next?
I'm not sure. No. When I say delegated and cooperative proof of stake, I'm talking about the BitShares block publication system,
Okay.
and then there's another one that's being proposed as a replacement for mining in Bitcoin, called cooperative proof of stake, where you have about 100 central players conduct all block generation and just cycle through.
Mm-hmm.
And so that you've got massive computing resources on those ends.
So, so what I would say about Next is, as Next grows, you've seen our hype that you can run Next on a Raspberry Pi. Yeah. We might need something slightly bigger, but we won't need massive computing power. What will need to be addressed is the network bandwidth for the transaction propagation. Because as you get more transactions, we will use up more network bandwidth propagating those, but we won't use more computing power other than the extra bit required to include the transactions in the block. Actually, forging the block will still be the same calculation it is today.
Right.
And what we have in terms of I think the equivalents, I haven't looked into those two features, but we already have stake leasing. So, for example, my stake is leased to another account. And that account itself may have, I don't know, 10 Next in it, which doesn't give it much stake, okay? But I can lease my effective balance to that account. Let's say I've got 500,000 Next. I can lease my effective balance to that account with a transaction on the blockchain, and basically that account then gets all the forging power of my 500,000. Yeah, and if someone else does it as well with 500,000 or 1 million, it gets that as well. And then my account doesn't even have to be online.
Yeah.
For the purposes of forging, that stake's now got 2 million Next. I also find it a useful security feature because the forging node needs the private key of the account in memory in order to forge. Clearly, if I've got 500,000, 1 million, or 2 million or more would be nice Next, then having my private key in a Java process online somewhere is a risk. Yeah, it's a small risk, but it's always a risk. The nice thing with leasing is you can have a node with a private key forging with 10 Next and signed transactions on the blockchain delegating or leasing the stake for another 30 million. And we've got a couple of very successful pools operating now with tens of millions of Next leased. And what the pool operator does is they get all of the fees from forging, and basically they send those fees to me periodically, a proportion to the stake that I've leased to them compared to the total stake in their pool. The nice thing is they don't need any more powerful computer than my laptop. They just need enough reliability in their network and whatever to run the pool. And basically I can still spend my Next the way we've implemented it, and it dynamically adjusts the stake that they've got. So if I spend 100,000 Next when they go to try and forge the next block, they've lost 100,000 of the least stake. It doesn't lock it up. It doesn't tie it up in any way, shape, or form.
Okay, this sounds like a really organic approach to removing the need for network propagation of transactions.
Transparent forging will be a cool feature when we have it, which will address the network propagation issue, and means that people can create a level of certainty of their transaction be included in a block, because they can make sure their transaction is broadcast to the correct node, and they're not relying on a whole load of other people retransmitting their transaction for them. We do typically, I mean, one of the nice things that the developers built in is timing changes. So if I want to move my lease, if I want to move my next, say, we have this thing called effective balance, and your balance doesn't become effective for 1440 blocks. So you can't pull hop or game the network by moving next around quickly, because if you move it, you effectively lose the forging ability for 24 hours. Well, imagine that I had two accounts. I leased one with one node and one with another, and let's say one node has just forged, so I move my next to the other account that's leased out to the other node. You know, it's like pool hopping with miners, because the moment you move your next, you can't forge for 24 hours, so there's no value in doing it.
It's well thought out. I suppose that's an essential feature if you're going to make leasing of stake a viable option. I guess I heard about Next potentially implementing multiple blockchains. Do you have anything to share on that development?
As far as I'm aware, in terms of parallel blockchains, that one has been pushed down the priority list at the moment.
It has?
Yeah. So I'm not aware of a current plan to build that particular feature. There are some others in the pipeline besides the transparent forging that's being worked on. Leasing is already there. We have the alias at the moment. You can't do anything with them, but we're about to implement essentially alias transfers. So people will be able to transfer and monetize that namespace in some way, shape or form. We have proposals on implementing voting on the blockchain. I'm not sure where that is, but the proposal's quite well developed. We also have under development a digital goods store, so the ability to essentially store and securely trade digital goods, so as in not physical goods. And something else that's also being talked about is account control, where you can actually secure the all or part of the account balance with an additional passphrase.
Because there is the possibility of two mnemonics accessing this, generating the same private key. Is that the case? So what people say is that because the next private key is based on 2 to the 64th, then and we're not basing it on a hash which is 2 to a higher power, there's a higher risk of collision regarding the same account number being generated by the same passphrase, but by different passphrases, essentially. So in theory, two different passphrases could generate the same account number, but you're talking about a 2 to the 64th space, which is a pretty big number. But the account is also protected by a public key, which is to the same strength as other cryptos. So it's a 256 key space. That means that once you've done one outgoing transaction from your next account, which is what we advise to do, even if it's just setting the name or setting an alias, then you've got a kind of almost zero chance of someone using a passphrase which will access your account that isn't the same as your passphrase.
but the odds are pretty astronomical anyway. But the people who are mathematically minded will make these comparisons.
2 to the 64th. That's pretty significant space to wander around in. Plenty of room to stretch your legs.
Yeah, I mean, people, in the same way, people are doing it. One of the issues that people have raised with NXT is the security of the passphrase, because we use a brain wallet passphrase directly in the client. Which means that if you use the passphrase 1 2 3 4 5 6 7 8 9, and you put some next in it, it's probably going to get stolen, because that's not a password, it's a passphrase. It's directly generating your keys, and somebody will have pre-computed that, will watch for a transaction against that number. If they see one, they will go in there with a bot and they will take money out.
Yeah, right.
Yeah? I think someone used the password "one small step for mankind" or something like that. His next was stolen.
Right.
Yeah? There are clients, so in the default client, we do generate strong passwords for you and ask you to record them. And there are clients like the DJX one, Offspring, which has a more traditional wallet.dat, which you can use. And I'm sure we'll see more clients in the future. But I think it's like everything else, people need to read the instructions and take care of their own security and use strong passphrases.
It does just take a different attitude toward a new and more enlightened attitude toward security. I know that people have lost money on Counterparty. I actually lost one of the words of my passphrase on Counterparty and managed to recover it with the help of the community. It was, it was a real eye opener though. Personally, I've made just about every mistake you can though in crypto and live to tell the tale. So.
Yeah, I've got fortunately a small amount of Bitcoin locked up in a Bitcoin wallet, and I signed the wallet with a password, and I can't remember the password. And the thing is, I'm paranoid about my passphrases and private keys, but I just didn't remember the password to this particular wallet. So. But it's only about half a Bitcoin. But I know what you mean.
Well, this has been really enlightening, and it's great to have in-depth description of what transparent forging's going to look like from someone who has at least some understanding of what's taking place. I suppose I have one casual question, and that's about NEM, a kind of a next clone that's been doing the rounds on the forums.
Yep.
It's beginning to gather a bit of interest, but I'm not sure what the core feature set of NEM is separate to what Next has, and also I'm wondering what you think its role and its relationship with Next is going to play out to be.
Okay. So, what I would say is as follows. I think if you think about things coming along like NEM, NXTL, Next itself, they're all innovative next generation coins or platforms, I should use the term, because they do more than just send a token of value. I do know that I am a stakeholder in NEM. I do know, and I see no conflict there, there's more than enough space for a number of innovative coins or innovative platforms looking at the next wave of digital currency type systems. NEM was taken and started by some people who were originally in Next, in the community. I have a lot of respect for the people who branched out there. They started by saying we're going to clone, and then they've actually had, I think, the courage to go in a different direction. I know that they're building in C++ rather than Java. I think they lose some advantage there. but equally, I think from some of the things I've read, they're going in a different direction. They're trying to invent a new mechanism, which seems to be some kind of hybrid of proof of stake and something else. And I look forward to seeing it launched and see what comes out. I think it will again add to the knowledge base of the crypto community about how you approach this stuff and how you do it. I don't think any crypto can be claimed to be perfect. Yeah.
It's interesting. I didn't realize they were changing the language that it was written in. I thought it was going to be in Java as well. So that's interesting to hear.
I heard it was C++. I need to check back, but that's what I believe it is. And I believe they've moved away from some of the core Next algorithms or evolved them. They've been working on it hard for a long time, and there are some smart guys in there. So, as there are in Next, but we don't have a monopoly on those. It'd be nice if we did, but we don't.
No, I think it's a good thing that we can get it, that it's being spread around. Yeah. Yeah, I mean, Next is really spawning a whole new breed of platforms, like you said.
I mean, we've talked about the core features, but there's a whole, and I talked briefly about the game we're hoping to kind of break new ground on. But there's a whole host of projects inside Next that people are looking to build new things on and around it.
Could you share your thoughts on some of the more exciting projects that are being developed?
I quite like the idea that you can write an email in your browser, it's encrypted there and then and stored on the blockchain, and basically it could never be read by anyone who didn't have the keys, and it's stored forever, which I think is great. There's another simple one which is being looked at, which I think could be quite useful. One of the issues with Next is it's so different to Bitcoin. Well, for the people out there with Bitcoin types, with systems that expect to integrate to a Bitcoin type API, there's a project called NextBridge, and basically what that does is it's like an adapter plug. It will convert the Next API into a Bitcoin API. So basically you can use the types of calls that you would expect to see from a Bitcoin clone to communicate with Next, which hopefully will simplify some of the... we recognize that people have to make investments to look at using Next. So actually, if they already use what I call a first generation crypto, why don't we create an adapter so to them we look like a first generation crypto and they can try us out. There's a really ambitious but exciting project called Multi-Gateway, and it's basically a kind of an exchange for other cryptos to be traded on the Next asset exchange. And basically you can register with the gateway. It gives you a wallet address for whichever coin you want to trade, and then you simply send coins to that wallet. They're secured by multiple gateways using multi-signature. So where a crypto allows its blocks to be signed by more than one key, we support that, and then two servers will sign and lock your balance, so no one can touch it. And the moment the deposit's confirmed, your coins will appear in your Next account as assets, and then you can trade. And then when you want to withdraw, you just send the coins back to the issuing account, and you'll withdraw, your coins will be sent back to whichever wallet you've registered for that particular external crypto. I imagine the ability of trading in that way, it's almost completely decentralized. The gateway servers can't be completely decentralized. Those will be run by trusted operators.
Yeah, that's a pity that you need that trust element in there. To remove that from the equation would really be a silver bullet for the agnostic wallets.
Yeah, I know. But imagine you've got three different operators running three different servers. So unless those operators collude, there's no chance, because each each transaction needs signing by at least 2 servers. There's no chance of any one person stealing the contents of those wallets. So I think it's a major step forward from where we are at the moment in terms of exchange security. But or trusting one organization. Maybe there will be an evolution of it still further. I don't know yet. But like I say, it's quite an ambitious project. It's being tested. I would say it's probably in beta at the moment.
I really look forward to seeing that completed. Coming from the perspective of someone with a bunch of different tokens, I don't really have anywhere to store them except spread across several exchanges.
Well, and the nice thing is you deposit them with the servers, and you can see them all in your next client as assets. You can actually store them there whether you want to trade them or not.
That's really fantastic, and again, that's what we're starting to see from Next.
I'm just hoping when the community listens to this, I've answered the questions closely enough.
yeah, I bet. I'm sure it'll be sweet.
It's been a pleasure, Arthur. Thank you very much. Have a good day.
That's all she wrote, folks. Thanks to Dan and Ian for joining me this week. You can find links to their respective websites in the notes. The New Zealand Department of Conservation provided the recording of the bellbird in song. Did you get that one? If not, don't worry. We'll have another mystery bird call next week. Also, thanks to Cesis for the tunes and all the other people involved behind the scenes. Without you, this would be more difficult and less musical. If you'd like to chat about anything you've heard here today, get in touch at beyondbitcoinshow@gmail.com. Also, check out the subreddit or the website, beyondbitcoin.fm, for information on guests and weekly developer hangouts hosted on our Mumble server. I'll see you all next week.